Welcome to EDU World Space.
Okay, so I see that you need help with this question. And it says clinical epidemiologists are interested in using measures of brain natriuretic peptide in the blood to diagnose heart failure. To investigate the potential use of BNP in this manner, they have launched a study and recruited 1,000 persons with known HF and 1,000 persons with known HF and measured BNP concentrations in the blood. The distribution of BNP values in both groups is shown in the histogram below. The epidemiologist also calculated an ROC curve to assess the performance of BNP as a diagnostic test. In the histogram, what pattern do you notice about the BNP values in persons with HF compared to persons without HF? So this is with HF, and then this is without HF. So in the histogram, we can see that the BNP values in persons with HF are generally higher than those without. So for A, it's persons with HF are generally higher than persons without. There is a clear separation between the two groups, with the majority of the persons in HF having BNP values of above 100 pg per million. So this is above 100 pg per million. And then we have here, okay. While the majority of the persons without HF having BNP values below 100 pg per million. So we can write that without HF is below, so less than 100, and then greater than 100 is with, sorry about that, greater than 100, and then without HF is less than 100. B, using the ROC curve, the epidemiologists believe that the optimal cut point for a BNP diagnostic test would yield a sensitivity of 0.87 and a false positive rate of 0.084. Why would they think that this is the optimal cut point? The epidemiologists would think that the optimal cut point for BNP diagnostic tests would yield a sensitivity of 0.877 and a false positive rate of 0.084 because the cut point would balance the trade-off between sensitivity and specificity. Sensitivity is the proportion of true positivities persons with HF correctly identified as having HF, while specificity is the proportion of true negatives persons without HF correctly identified as not having HF. A high sensitivity means that the test can correctly identify most persons with HF, while a high specificity means that the test can correctly identify most persons without HF. However, there is often a trade-off between sensitivity and specificity, as increasing one may decrease the other. The optimal optimal out point is the one that maximizes both sensitivity and specificity and minimizes the false positives and false negatives. Okay, so that answers B. C, at the ultimate out point, the false positive rate is 0.084, which means that 8.4% of persons without HF in the study would be incorrectly diagnosed. as having HF based on their BNP values. Having HF based on their BNP levels. Therefore, the proportion of participants without HF in the study who would be correctly diagnosed as not having HF based on their values would be 1 minus 0.084 equals 0.916, which is 91.6%. So I hope that this video helps. This is the math teacher signing out.